Okay, in our last class, we discussed about the preparation or synthesis of di-alkyl alane. More particularly, let's give an entry. Okay, so more particularly, the synthesis of trialkyl halane and its application in more particularly the synthesis of hydroalumination product, carboalumination product, and oxidation, conversion of alkene to alcohols, conversion of a 1,6 die into 6-membered ring, 1,5 die into 5-membered ring. So we know that what is hydroalumination, and also we know that what is carboalumination. Carbon as well as aluminum is added to double bond means it's a carboalumination. Hydrogen as well as aluminum will add to double bond means it's called hydroalumination. So, in addition to this, today we will discuss more of use of trialkyl alane in organic synthesis. So, more particularly, you are aware about a nucleophilic substitution reaction and also nucleophilic addition reaction. So, what is nucleophilic substitution reaction? If in a substrate, if we are replacing with the living group with a better nucleophile, it's a substitution reaction. If we are adding, for example, hydroiodic acid to a double bond or carbonyl compounds, that is called addition reaction. So in the addition, a double bond addition is different, a carbonyl carbon addition is different. But here what I'm, let's give an entry. Okay. So here I am talking about the addition to the carbonyl compound. So this, if you are adding HCN to this, cyanohydrin is the product, and the reaction is called nucleophilic addition reaction. Similarly, here also we are adding a aluminum and then hydride. Okay, so of course we can call it as a hydroalumination. Okay, so hydroalumination of benzaldehyde or aldehyde gives alcohol. Of course, this is the byproduct. So this is the reaction. So what is the reaction? Conversion of an aldehyde to alcohol by using triisobutyl alane, followed by hydrolysis. This hydrolysis, what is the need of doing hydrolysis? Just to cleave the aluminum bond. Aluminum is replaced with proton. Okay, that for that purpose, hydrolysis means water in presence of H plus, otherwise hydronium ion means H3O plus. So this is an example of nucleophilic substitution reaction. It's not substitution, it's addition reaction, nucleophilic addition reaction. So here what is the reagent? Reagent is a triisobutyl alane. Triisobutyl alane add to aldehyde. How it is adding? So that we need to look into the mechanism. Look here. So here this is an isobutyl group. Okay. So this isobutyl group is bonded with aluminum. This aluminum will bonded with 2 molecules of isobutyl moiety. So you can observe that this is an aldehyde. So here H, okay, H of the isobutyl group. What we can say that hydride, H minus hydride. Hydride will add to carbonyl carbon. And similarly, there will be a bond formation between the oxygen and aluminum. And you can observe that there are a 6 electron, and this will be the transition state for the formation of alcohol. Okay. Uh, then what it means, this H minus will add to this carbon. That means there will be a new bond formation between the carbonyl carbon and hydride of isobutyl group. Similarly, there will be a new bond formation between the oxygen and aluminum. So that's what I have written here. This is an intermediate. And this is a gas, isobutene gas. It will go out. Let's give an entry. Okay. So isobutene is a gas. It will go out. Then what is the product obtained? The product obtained is uh, benzyl alcohol. Let's give an entry. Okay. So here benzaldehyde is converted into benzyl alcohol. It's a reduction. So reduction means in this case isobutyl, triisobutyl alane will act as a source of H minus. So that means one of the group of the isobutane group gives H minus to the carbonyl carbon. So that is the reason isobutene is a byproduct and it is a gas. It will evaporate, and the cleavage of aluminum is achieved by using hydronium ion. Hydronium ion means hydrolysis. Hydrolysis means H3O plus. So this is about what is called as the nucleophilic addition reaction to the carbonyl compounds. Carbonyl compound may be a aldehyde or may be a ketone. So here aldehyde or ketone, when it is treated with trialkyl halane, for example, triisobutyl halane, the product is alcohol. Alcohol means benzyl alcohol. And the mechanism involves a concerted transition state where there is an involvement of 6 electron system. Okay, so in this, a hydride is transferred from the isobutene group to the carbonyl carbon. So thereby it will form an intermediate. This intermediate on hydrolysis. Hydrolysis means breakage of aluminum bond between the oxygen and aluminum, and thereby benzyl alcohol is obtained. And of course, this is a byproduct. So what is the name of this byproduct? Uh, Diisobutyl aluminum hydroxy group is the byproduct. So with this, I will go to the next slide. So look here. Here I am taking examples. Okay. I am taking same benzaldehyde itself. So benzaldehyde, when it is treated with what is called as trimethyl alane. So trimethyl alane, here in the trimethyl alane, it does not act as a source of hydride, but it will act as a source of methyl group. So we can also categorize this into a carboalumination. Carboalumination followed by hydrolysis gives alcohol. So what type of alcohol it is? It is what is called phenethyl. Okay, you know that this group is called phenyl group, and this group is called ethanol. Okay, phenyl ethanol, otherwise phenethanol, phenethylamine. Okay, it's a phenyl ethanol. Okay, right. This has a wide application because phenethylamine, it's an optical, of course, this is also optically active compound. Okay, so that is the reason. In addition to that, This also had a wide application in many commercial purpose. Okay, so the heat, you can also observe that the yield 77%, theoretically 70%, 77 percentage of product is formed. It's a good thing. Then here, uh, okay, so this byproduct is not required for you. This is not the byproduct in this reaction. Okay, this you can erase it. And here I am taking uh, so here I am taking a triethyl alane. So triethyl halane, when it is treated with benzaldehyde, so what is happening? It will act as a source of ethyl group. So here I have written as a methyl group. This you have to convert into a ethyl. Ethyl means C2H5. And of course, this is the byproduct, 12% byproduct. So that means this is one byproduct is formed in this reaction. If you want to look into the mechanism for the formation of benzyl alcohol, you should look back to the one reaction I mentioned. So in that reaction, how the hydride will add to carbonyl carbon. So just by the transfer of hydride. So here transfer of hydride from the ethyl group, ethene is the byproduct. Ethene will go out. So that is how a benzyl alcohol is obtained. Of course, it's a 12% product. And the major product is 63%. And the 63% product is, again, it's called, of course, you need to change this as a ethyl. So ethyl means phenyl propanol. Okay, more particularly, we have to say that 1-propanol, phenyl 1-propanol. Okay, these are the two products. Okay, so maybe if you want to write the mechanism, you have to follow the previous one. So that means this one. Okay, a 6-membered transition state 1. And then with this, I will go to the next concept that's called hydrocyanation. So hydrocyanation means here hydrogen as well as cyanide group is added to the double bond. So then it is called hydrocyanation. So there are questions on this. What is hydrocyanation? So then you can explain about this. Hydrocyanation means addition of hydrogen cyanide to a alpha beta unsaturated carbonyl compounds and to give beta cyanoketones. So beta cyanoketone. By this method, cyano group can be introduced into the organic molecule. I think you should aware that. So addition of cyano, I think you are aware about what is called as hazardous. Okay, more particularly, hydrogen cyanide is a gas and it is very dangerous. Okay, just inhale, that leads to the death because it will block the hemoglobin. Okay, so that means it will form a complex with the uh, hemoglobin. So thereby it will stop the respiration and thereby it will turn the color of the body. So since the HCN usage is difficult, so people will look for other alternative. So this is one other alternative. That means diethyl aluminum cyanide is the reagent. Here, what is happening? a cyano group means CN group can be introduced to the beta carbon, and this is alpha carbon, this is beta carbon, and okay, and this reaction is called hydrocyanation reaction. Di-alkyl aluminum cyanide is the name of this particular compound. Di-ethyl aluminum cyanide is the name of the reagent, so which is responsible for the conversion of alpha beta unsaturated carbonyl compound to the beta cyano-ketones. So this is alpha position, this is beta position. Beta cyano-ketone is the name of this product. Okay, so then how it is converting? I think you are aware about cyanide. CN will add to this carbon, and this carbon form a bond with aluminum. So once it is hydrolyzed, Al is replaced with hydrogen. So that is how a cyano-ketone is obtained. So here I am taking one more example, a substituted product. So I think you know that what is the name of this compound? Without this double bond, it's called a tetralone. Is it a tetralone? Decalone. Okay, it's a decalone. Of course, it's also a decalone. A substituted chloroacetoxy substituted decalone. Then here cyanide will add to this carbon, and aluminum will form a bond with this carbon, and aluminum on hydrolysis, aluminum is replaced with proton. So that is how a beta cyano-ketone is obtained. So overall, what you need to write, hydrocyanation means hydrocyanation is the process where there is a conversion of alpha beta unsaturated ketone into a beta cyano ketone. So this is achieved by taking a dialkyl aluminum cyanide as the reagent. Okay, this is about this is the best method for the introduction of cyano group to the substrate. So this much information you can write. If it is a 4 marks question, so normally it is asked for the 2 marks question. If it is a 4 marks question, you write all these things. If it is a 2 marks question, you just give an definition. Maybe if you are writing this also fine, conjugate addition of hydrogen cyanide, okay, to a alpha beta unsaturated ketone gives beta cyano-ketone. This method is a good method for the introduction of cyano group to the organic molecule or substrate. Okay, this reaction is called hydrocyanation reaction, and this will be the example. So that much if you are writing, that's also fine. Then we'll take up another molecule, what is called as alkenyl di-alkyl alane. Okay, so we discussed about what is called as di-alkyl aluminum hydride. So di-alkyl aluminum hydride that will react with alkene, forming hydroalumination reaction. Okay, and one more molecule we discussed. That is what is called as trialkyl aluminum, trialkyl alane compounds. So what is trialkyl alane? So its synthesis and its application also we discussed. Now we have to discuss about alkenyl. Alkenyl means double bond containing one. Okay, double bond or vinyl group containing, and other two substituent to the aluminum is dialkyl. So that reagent, okay, this is also one of the reagent of aluminum organoaluminium compounds. So let's look into the preparation, more particularly preparation of alkenyl. Okay, alkenyl dialkyl alane. So alkenyl means double bond containing one. Dialkyl means two alkyl group containing, and alane means aluminum compound. How we can synthesize? So here hydroalumination of alkynes. So here that means alkynes is the starting material. Using an alkyne, when it is treated with hydro, this is hydroalumination. Hydrogen as well as aluminum is added to triple bond. So what is the obtained? Obtained compound is called alkenyl. This is alkenyl, di-alkyl, alane. So this is only the compound, and this is what the preparation of alkenyl dialkyl alane started with alkyne, and this alkyne when it is treated with dialkyl aluminum hydride. So what is happening? Hydroalumination is happening. That means hydride will add to more substituted carbon atom. Aluminum will add to less substituted carbon atom. That is how a alkenyl dialkyl alane is obtained. The obtained alkenyl dialkyl alane, when it is treated with iodine, so what it will do? Iodine will replace the aluminum group. So that means iodine will form a bond with this. So this is how a compound is obtained. Iodoalkene is obtained. So iodoalkene is obtained via the alkenyl dialkyl alane. Suppose if we are treating this alkenyl dialkyl alane with bromine, what will happen? Bromine will replace aluminum group, forming a bromoalkene compound. Okay, so now let's look into the carboalumination. So carboalumination means carbon as well as what is called as alumina is added to uh, triple bond. A carbon means ethyl group. Ethyl group and aluminum group will add to alkyl. So here ethyl group will add to this carbon, and alumina group will add to this carbon. So in this structure, you need to change this hydrogen as a ethyl group. Then only we can say that carboalumination. Okay. And then let's look into the properties. Properties and the reactions, both are same. Reactions of alkenyl, dialkyl, alane. Otherwise, properties of alkenyl, dialkyl, alane. So first one is protonation. So protonation means alkenyl dialkyl alane when it is treated with proton source. The proton source means hydronium ion. So hydronium ion means water in presence of H plus. So that means aluminum group is replaced with H plus. So that means obtained one is alkene. Similarly, this alkenyl dialkyl alane, when it is treated with NCS, I think you are aware about NBS. NBS is called N-bromosuccinamide. NCS means N-chlorosuccinamide. So that means NCS will act as a source of chlorine. So then what it will do? It replaces the aluminum group. So that means Cl is obtained. And then I will discuss more examples of this kind. So look here. Suppose alkenyl dialkyl alane, when it is treated with aldehyde. So what is the aldehyde? Alkyl halide or aryl halide. So what will happen? This carbon will act as an anion. So that means this bond pair attack this carbon. Okay, aldehyde is converted into alcohol. This is the product obtained. Of course, this is a byproduct. This byproduct, how it is obtained? By the transfer of one of the hydrogen from the isobutene group. From the isobutene group, if isobutene group is transferred hydrogen to the aldehyde, then benzyl aldehyde, then alcohol will be the one of the byproduct. Okay, suppose if alkenyl dialkyl alane is treated with ketone, okay, or CO, R dash means ketone, what will happen? There will be a new bond formation between this carbon and this carbonyl carbon. Alcohol is obtained. Okay, yeah, what is it? Alcohol? Is it more particularly enol? Enol. So enol is the product. Okay, what it means? It means that a alkenyl dialkyl alane, when it is treated with aldehyde or ketone, it gives enol. Okay, is it a enol? Of course, it is a enol, but the ene is not present at the first carbon, alpha carbon. It is double bond is present at the beta carbon. If it is a alpha enol means what it will do? It will convert easily into ketone or aldehyde, right? And again, here I am taking a symmetrical alkyne. This symmetrical alkyne, when it is treated with what is called as a triethyl alane. So in this case, ethyl group transfers hydrogen to the substrate. Okay, what is happening here? Hydroalumination reaction is happening, and then this hydroaluminated product on hydrolysis, what it will do? Aluminum group is replaced with proton, and then nucleophilic addition reaction. Of course, what is happening here? You can observe that what is the name of this compound? Name of this compound is called alkenyl dialkyl alane. So I am talking about the general name, okay, because R is there, no? That is the reason. So alkenyl dialkyl alane, when it is treated with methyl lithium. What is methyl lithium? So methyl lithium is a base. What it will do? You know that aluminum will have a lone pair. So that lone pair can it can accept a electrons from the methyl group. So that means when it is accepting an electron from the methyl group, aluminum is converted into anion, and that anion is neutralized by Li plus. So I think you are aware about the difference between these two molecules. So this is alkenyl dialkyl alane, and this is alanine. Okay, I think you are aware about the ethanol and sodium ethoxide. Okay, ethanol, sodium ethoxide. Once ethanol is converted into anion, it's called ethoxide. Similarly, alane, when it is treated with methyl lithium, it will convert as a alanate. Alanate because of the presence of Li. Li means aluminum will be formation. Aluminum will be in the form of anion. So this alanate. So here one sentence is there. You just read out. Alkenyl dialkyl alane reacts with carbonyl compounds with retention of configuration about the carbon-carbon double bond of alkenyl group. You know that this is what is called as a double bond. So double bond means if there is a different groups, more particularly A is not equal to B and A dash is not equal to B dash. In such case, that double bond exhibits as a geometrical isomerism. Of course, geometrical isomerism is also a very important. So many drugs, okay, for example, I think you are aware about Actifed, Cold Act, okay, Actifed, Cold Act are the drugs, okay, used for cold, okay, and these will act as a antihistamines. Okay, antihistamines. More particularly, a compound called tripolidine. So trans tripolidine is active, physiologically active, whereas the cis one is not active. So in such case, retention of configuration is important. If you are during the process, if trans is converted into cis means cis will be physiologically inactive means then it won't be useful. So that is the reason in that cases. So here what I am taking, I am taking one uh, uh, alkenyl dialkyl alane. Alkenyl dialkyl alane, when it is treated with acetone. So when it is treated with acetone, what it will form? So more particularly, this acetone in presence of methyl lithium. So methyl lithium, what it will do? It will convert Al into alanate. So once this Al into alanate, this bond pair can form a bond with this carbonyl carbon, and that on hydrolysis gives substituted product. And this substitution does not affect the stereochemistry of the double bond present in it. So that is the speciality about this reaction. Similarly, this alkenyl dialkyl alane, when it is treated with benzaldehyde, alcohol is obtained. So before treating with benzaldehyde, this alkenyl dialkyl halane should treat with methyl lithium. So methyl lithium will convert this alane into alanate. Okay, that alanate react with this carbonyl carbon, more particularly this carbon, forming a compound like this. So don't worry about this name. This name is not required here. And similarly, this alkenyl dialkyl alane, when it is treated with cyclohexyl carboxaldehyde, C6H11CHO means cyclohexyl carboxaldehyde. So this is also a carbonyl carbon. The bond, okay, this the bond between the carbon-carbon double bond and alane. It will form a new bond with this carbonyl carbon and converting CO into COH. Okay, this is how the product is obtained. So so overall, what you need to remember? You need to remember that a alkenyl dialkyl alane, when it is treated with methyl lithium, it will form a alanate. That alanate react with electrophile, carbon electrophile. So what are the carbon electrophile? Aldehyde is a carbon electrophile, acetone is a carbon electrophile. Okay, the C plus having species are called carbon electrophile. So with this, I will go to the next slide. So here I am taking a few more examples. More particularly, here what is called one catalyst is used. For that, what you just read out this. Formaldehyde gives nucleophilic addition reactions only when alane is converted into alanate complex with alkyl lithium. Alkyl lithium means maybe a methyl lithium or ethyl lithium or propyl lithium or butyl lithium or hexyl lithium or pentyl lithium, eptyl lithium. Okay. So what is happening here? Dichloro diethyl zirconate. Dichloro diethyl zirconate is a catalyst. So this catalyst, what it will do, it will, if the reaction is carried out, an alkyne, this is an alkyne. Alkyne, when it is treated with diethyl, triethyl, dimethyl alane. So what it will do, it will transfer methyl group to the more substituted carbon atom, and aluminum will form a bond with this. So that is how intermediate is obtained. So the obtained intermediate, when it is treated with methyl lithium, what it will do? It will convert alane into alanate. How it will convert? There will be a new bond formation between this aluminum to the methyl group, and at the same time there will be anion formation. That's what I have written. This is the alanate. Now this is ready for the nucleophilic substitution reaction. Nucleophilic substitution reaction means, so what it will do, this will act as a nucleophile and there will be a new bond formation between this carbon and this carbon. What is the name of this carbon? What is the name of this compound? Name of this compound is called formaldehyde. What it means? So formaldehyde can react only with the alane. Okay. So that means this alane is not reacting with the formaldehyde. Alanate only reacts with the formaldehyde. So once there is a bond formation between this carbon and this carbon, this C double bond O is converted into CH to OH. So this is how one can convert a triple bond into a this particular compound. Say one more example I'm giving this kind. So look here, this is one triple bond. So in this triple bond, when it is treated with trialkyl alane, what it will do, trialkyl alane, and this is a catalyst. Dichloro diethyl zirconium is a catalyst. So what it will do, methyl group will add to this carbon and alane group will add to this carbon. Afterwards, when it is treated with dimethyl lithium, it converts alane into alanate. Once the alanate is formed, that alanate reacts with formaldehyde. That means there will be a new bond formation between this carbon and carbonyl carbon of formaldehyde. And that on hydrolysis giving rise to product like this. So what you can observe, the stereochemistry is retained. Here the triple bond and this is the double bond. Stereochemistry is retained. So now one more example I am taking of this kind. So look here, what is this? It's a alanate. This alanate, when it is treated with carbonyl carbon, so means electrophile. So there will be a new bond formation between this carbon and this is CHO. CHO is converted into OH. This is the product. So with this, I will go to the next concept that is called reaction of alkenyl di-alkyl alane with carbon dioxide. Carbon means nitrile and chloroformate. All this carbon dioxide, nitrile and chloroformate are the electrophiles. So what is happening? Just let us look into this. Okay. So this is what is called alkyne. Alkyne means triple bond. So to this triple bond, what is called as triethyl alane. So carboalumination occurs. Carbon will add to this carbon and aluminum will add to this carbon. Of course, this reaction can be carried out in presence of dichloro diethyl zirconate. That's a catalyst. So carboalumination is the product. This carboalumination, when it is treated with organoaluminium, it will form a alanate. This alanate is ready for the nucleophilic substitution reaction. This will act as a nucleophile. So then there will be a new bond formation between this carbon and this electron deficient carbonyl carbon. So that means there is a new bond formation. That means there will be a new bond formation like this, and this will go out as a byproduct. So that is how a carboxylic acid is obtained with the retention of configuration. So here I am taking one more example of similar kind. Of course, this is a unsymmetrical alkene. Since it is a unsymmetrical one, what is methyl group will add to more substituted carbon atom, and aluminum will add to less substituted carbon atom, and the conversion of this to this is called carbo alumination. And this carbo aluminated product, when it is treated with methyl lithium, so there will be a anion formation on the lithium, and the obtained compound is called alanate. This alanate is now ready for the nucleophilic substitution reaction. What it will do, there will be a, it will form a new bond. Okay, it will form a new bond between this carbon and this nitride. So that is how a compound is obtained. Similarly, here I am taking one more example. So what is happening here? This is a unsymmetrical ketone. Suppose R is equal to other than H. If R is equal to H, again it's a symmetrical one. So what is the reagent here? Di-alkyl aluminum hydride. So that means hydride should add to more substituted carbon, and aluminum will add to less substituted carbon atom. Initially there will be a hydroalumination. Then afterwards what it will do, the obtained aluminum carbon aluminum bond, so that will act as a nucleophile when it is treated with methyl lithium, and there will be a new bond formation between this carbon and this carbonyl carbon. So that is how a compound is obtained. Okay, so few more example also I will discuss. So what is that nucleophilic substitution reaction? Here, this particular bond, there will be a new bond formation between this carbon and this carbon. So that is how the product is obtained. And this particular one, when it is treated with methyl lithium, this alane is converted into alanate, and now that is this one is ready for the nucleophilic substitution. So there will be a new bond formation between this carbon and this electrophile, means alkyl halide. So that is how carbon-carbon new bond is formed. And then here also, when this is treated with methyl lithium, alanate is obtained, and that it will form a new bond with the benzyl group, means phenyl bromide, bromobenzene. So that is how a compound is obtained. Similarly, so this alane, when it is treated with methyl lithium, alanate is obtained, and then it will form a new bond with this moiety. So this group, what is the name of this group? OSO2CH3. I think you are aware about mesylate. So name of this compound is a mesylate. This is a better living group. I think you know that alcohol is converted into tosylate. Okay, but here this is a mesylate. This will go out. OSO2CH3 will go out. There will be a new bond formation between this carbon and R. Similarly, this alane, when it is treated with methyl lithium, alanate is obtained, and the obtained alanate will have a nucleophilic nature, and there will be a new bond formation between this carbon and this bromine. So that is how the product is obtained. Similarly, what you can observe here also, same reagent. What is that? Methyl lithium reagent. That will convert alane to alanate, and then there will be a new bond formation between this carbon and this triple bond. So that is how the product is obtained. Similarly, when this moiety, okay, what is the name of this compound? It's a halane. This halane, when it is treated with methyl lithium, it forms a alanate. Then there will be a new bond formation between this carbon and this end of the epoxide. Why this end? This end is the what is called as less hindered, whereas this one is more hindered. So it will open up, epoxide will open up, forming a alcohol. This is about what is called as alkenyl, uh, di-alkyl, alane synthesis and its application. So overall, under the heading of organoaluminium compounds, we discussed three important organoaluminium compound. One is dialkyl, uh, uh, dialkyl aluminum hydride. Another one is trialkyl alane, and the third one is alkenyl dialkyl alane. So these three preparation and its reactions we discussed. So all these three will act as a will useful in the organic synthesis. Okay, that's what the uh, that's what about organolithium. And one more is left over, that's called organocopper. So that I will discuss in the next class. Okay. So maybe by today I'm giving notes of organo metallic compounds.